Hi, my name is Florian Meyer. I'm an assistant professor for information studies at Aalborg University in Copenhagen in Denmark. And together with my colleagues Birger Larsen and Frederik Sternfeld, we tried to find out whether we could use a method called the Bootstrap consensus networks to identify all the unknown authors in the freedom of the press writings, the Trykkefrihedsskrifter. I want to walk you through those 4 points today. So basically, I want to present the freedom of the press writings and our data set in that sense. I want to quickly say what authorship attribution is, and then present the Bootstrap consensus networks, and finally talk about our main research question, basically, which is, can a text analysis method that is designed to support distant reading, as the Bootstrap consensus networks originally are, also be used in authorship attribution tasks. So first of all, what are the freedom of the press writings? So at the end of the 18th century, Struensee, who was the physician to King Christian VII, rose to power as a de facto regent of the Kingdom of Denmark and Norway. And one of his first cabinet orders was the abolition of the censorship, and he proclaimed the freedom of the press, which then led to an unprecedented publication of ideas in the form of books or pamphlets, which discussed a lot of different topics like church, so how much should the cleric earn, economy, societal conditions, and patriotism in general. And luckily, this guy on the right here, Bolle Luxdorf, he was also a governmental official, and he collected around 1,000 of these texts, which are referred to as the freedom of the press writings. Our work is not the only one, or my work here is not the only one who deals with those. Our colleague Frederik Sternfeld, and this is basically a bit of advertising here, he wrote together with Henrik Korsbøl and Ulrik Lang 2,000 page heavy book on those freedom of the press writings and about all those discussions that were going on at that time. So yeah, that's our data set. But the problem with this data set is that like half of those around 1,000 pamphlets are of unknown authorship. So the question is, how can we actually find out who might have been the authors of those pamphlets? And that's where authorship attribution comes into play here. So what is authorship attribution? It's basically a field in quantitative text analysis and stylometry that tries to find an answer to simply the question, who is the true author of a text? So imagine the following situation, that you have candidate authors and texts written by those authors, and then you want to find out or find an answer to the question, can texts of unknown or disputed authorship be attributed to one of these candidates? And of course, the underlying fundamental assumption of authorship attribution is that individuals have an idiosyncratic and largely unconscious habit of language use, leading to stylistic similarities between texts that they have written, and which make them very separatable from texts that other people might have written, because they just have a different writing style. Good. Yeah, there are many methods out there, and depending on the discipline where it is used, so it's not only used in the digital humanities, but of course also maybe in law cases and so on, to find out maybe if a murder was the author of an SMS, for example. But there are, of course, machine learning methods like latent Dirichlet allocation is used also for authorship attribution, the technique one knows from topic modeling. Then there are, of course, also now deep learning architectures that are used, or also compression models. And another perspective or another area is our similarity-based methods, where we use feature vectors, and in those features those could be of different kind, like regular tokens, n-grams, or TF-IDF values, and distance measures like Euclidean distance or delta distance to find out about how close or how similar are two texts in that sense. And of course, if they are similar, then they are also likely by the same author, especially if we're covering style. similarity-based methods are very popular in the digital humanities because they also allow for meaningful visualizations like dendrograms, as I will show on the next slide. So usually what then happens with those vectors is that in similarity-based methods, some kind of algorithm comes into play, like hierarchical clustering. And what you try to then do is cluster those books or texts that are similar, and also then of course visualize that. So that's basically one advantage here, that you can actually, it's not completely black box. In the end you get a nice visualization, for example, with those dendrograms. Here just an example of a cluster analysis of 66 English novels, and you see that then of course like Jane Austen books are in one group down there, because like they are of course by the same author. But also this looks promising. Those dendrograms, or this stellometric approach with hierarchical clustering, has some drawbacks, and that's where Bootstrap consensus networks come into play. So the problem is that the final shape of those dendrograms highly depends on many factors, like what distance measure is used, what clustering algorithm is used, in the number and types of features, of course. And larger number of texts also are very difficult to visualize. I mean, you have seen that before with those 66 books. If you get like 100, 200, 300 texts, then a dendrogram is simply not readable anymore. And this is basically where those Bootstrap consensus networks come to rescue, because they visualize text and their relation as a network. So the nodes of a network are the text and the books, and edges or links between those books are basically a mapping of a textual relation. And this is based on two algorithms, basically, and this is where also the terms bootstrapping and consensus comes into play. Because what we're doing is we are building a link between a node or two nodes, basically, if they are identified as the nearest neighbor. So there is an algorithm that identifies that, and then there is an algorithm which is part of those Bootstrap consensus networks that produces consensus networks. So which means that we are using different samples of our data set, and then build different smaller networks, and then build one over all agreeing network out of that. So that looks a bit like that. Good. This is an example of a Bootstrap consensus networks, also from our Freedom of the Press writings. It's a weighted directed networks. The nodes are texts, the edges and links between those texts represent stylistic similarity, or are at least supposed to, because we use the n-gram features here. The nodes are sized by in-degree, and the colors are here the result of community detection algorithm. So this is when you use that basically method for distant reading as it was basically intended to. But the question that we now try to investigate is also, can this method be used to do authorship attribution, and maybe find out about unknown authors of a text if we only use, for example, the nearest neighbors and so on to our nodes. So we are investigating this question, as I said, a method that is originally used for a distant reading, like this BCN method is. Can it also be used for authorship attribution? So we have our data sets. We had to filter a lot of those pamphlets because a lot of them are also non-Danish and non-prosaic texts. So there are also just basic lists in there that you need to filter out. And then in the end, we had like 725 pamphlets that we could work with in Danish and in prosaic text. Then if you look at the author distribution here, you can see that 360 are of unknown authorship, and that's quite a lot. Then we built a bag of word-based word vectors representations for this data set with features in those word vectors. We used character engrams or character shingles with and without punctuation from only 1 character to 5, and regular token engrams from 1 to 3. We used different distance measures to find out whether this method or whether this has an effect on the network that gets built. We used Euclidean and delta distance. And then for the creation of the Bootstrap consensus network, so in total we compared 26 variations. Those were undirected, basically meaning there is no direction in the link or in the edge. And only the nearest neighbor was used, which makes sense because we want to only have one connection between the node. If it is there, then it's likely maybe of the same author. And we used between 100 and 1000 of the most frequent words, or basically of the most frequent features here. And as I said, in total, there were 26 variations that we compared. So maybe quickly before I show you the overall result table. So we had, of course, some evaluation measures here. Basically false attribution, or this is more or less just inspired from information retrieval or general machine learning, right? A result. So if you have a false attribution, if a link between two books written by different authors gets produced by the network, you have a correct attribution if a link between two books written by the same author gets created, and so on and so on. And a possible attribution is, of course, a link between a book where we know the author and where we don't know the author. Problematic is a relation where we have a situation where both authors are unknown, which doesn't really help us much in that sense, because we might know who the author is, right? There might be one that we don't know of and might be or could be prominent in the collection. So in the end, we looked at the precision, right? We looked at how many, or what's the relation of the correct attributions compared to all the correct and false attributions. So this is the overall result table. Don't worry, you don't need to read that in detail. What I want to make you aware of is the following. Here is the number of total links, where we can see that depending on what combination we use on distance measure and the number of features and so, it varies quite strongly between how many links between our books get created, right? From only 600, around 622 links, or exactly 622 links, to more than 3,500, and this is quite a lot, right? So depending on what features you use, you see that there are different kind of links that get created. Then regarding the precision, if you look at all edge weights, so what I might not have mentioned before is that, of course, those links between those books, they also have a weight. So, and the stronger that weight is, the more likely this is an actional, or the stronger the similarity between those nodes is. If you look at basically all edge weight groups, also between very low ones, then the highest precision that can be reached is around 30%, which is very low. But if you look at only the maximum edge weight, which is basically in the top category, then you can see that you can actually reach a precision of 90% attribution here. The problem is a bit that in this edge weight group, there are not that many attributions that get actually made in that sense, right? So this is run ID 19 with the highest precision of 90%. But the problem here is that only 19 edges can be observed there, and 7 of those are 2 texts by unknown authorship. So where we can actually see or say, maybe this is a possible attribution that we could do here. And this is actually very low, right? So, or it's not really helpful in the large scale kind of approach here that we wanted to do. So what we also tried to find out is whether there is some kind of threshold where we can still have some or more attributions, possible attributions, but also a kind of a reasonable precision. So that was basically also one of those questions that we tried to investigate. And we can see here that we go into, if we go into the edge weight group that is bigger than 4, we see that the number of possible attributions drops quite a bit, right? So which is depicted on the y-axis here. And if we want to have a reasonable precision that is around like maybe 75%, 80%, then we end up in a very high edge group where only a small number of attributions is possible. So one can say that there is no reasonable situation where authorship attribution could be done at a large scale, because the precision is simply too low for the number of possible attributions that we would actually want to make, or on the other way around, it is not really possible to identify many if we have a high precision. So final slide here, what are the limitations, conclusions, and some future work. So the Bootstrap consensus network doesn't seem to be a good fit for large-scale authorship attributions. We can see that, or we can say that this is a real-world case, right? And the reasons for poor precision in some cases can be manifold. We have a lot of OCR errors still in here. It could be that it is a challenging data set in general. The BCN method solves some problems of this one snapshot at a time visualizations like that dendrogram, but nevertheless, it gives good visualizations in that sense for distant reading, but it doesn't really help much in authorship attribution. And if we construct those Bootstrap consensus networks, they are very sensitive to other methods or features as well, like the distance measure and so on. So the number of nodes that gets created is quite different. Varies quite a bit. One perspective of future work would of course be to apply it more systematically to data sets with all known authorship to find out whether it could be just a case that we're dealing with a really challenging real world case here. For the perspective of really identifying all the unknown authors in the freedom of the press writings, one should apply a different machine learning based approaches and see whether one could identify all those unknown authors. That's the end of my talk, and I thank you for your attention, and I'm ready for questions now.